Hello everyone. So in the previous videos we saw Sieve of Eratosthenes algorithm, and in this video we will do some problems on that. So let's read the problem. Peter wants to generate some prime numbers for its crypto system. Help him. Your task is to generate all prime numbers between two given numbers. In this you are given test case, and in each test case you are given two numbers m and n. The important point to note that M and N is very large, 10 to the power 9, but the difference is only up to 10 to the power 5, and you have to print all the prime number between that range. So let's suppose you are given 2 to 6, so you have to print all the prime number between this 2, 3, and 5, right? Now you can't just calculate all the prime number up to 1 and R, and out of this take out all the prime number from L to R. This will not work because in this case the time constant will become over 10 to the power 9. So give TLE. Instead, you have to use segmented sieve, which I discussed in the previous video. In that algorithm, let me briefly tell you how to apply segmented sieve. You first find all the prime number from 1 to root r and use it will give you a vector of primes, and use these primes to remove all the composite number from L to R. Means iterate on these primes, and multiple of these primes, take out the first prime, iterate on the multiple of this prime, p into 2, p into 3, and mark that as false. And finally the number, the element whose is marked true is your required prime number. So let's see the code. In this code, this is the segmented sieve code in which you are first finding all the primes number up to root r, and then you are iterating on that prime number, and you are going on the multiple of I and marking that as false, and you are returning the prime number. This vector is basically converted to zero index because uh, you can't make an array of length r. You have to shift that window. So in this segmented sieve, the first index is L, second index is L plus 1, and third index is L plus 3, and so on. So you iterate from L to R, and you check whether u of I minus L is 1, and if it is 1, it is a prime number, and you are outputting that answer. I already checked it, and yeah, it's working. Let's see this problem. This is a good one. So in this, you are given n piece of jewelry, and the ith piece has price equals to I plus 1. That is, the prices are 2, 3, 4, 2, n plus 1. And you have to color these jewelry such that two pieces don't have the same color if the price of one piece is a prime divisor of the prime piece of other piece. And you have to minimize the number of different colors used. So let's take 4. So what is the prices of jewelry? 2, 3, 4, and 5. Now in this you have to color. You can't give 2 and 4 same color because 2 is a prime divisor of 4. So you give here 1, 1, you have to give it 2, you have to give it 1. And let's suppose here it is 6, 7. So you can't give 6, 1. because 3 is a prime divisor of 6 and 2 is also a prime divisor of 6, right? So in this case, you need two color to minimum two color, right? So what you can observe that, let's suppose you are looking at a number I. First of all, if I is a prime number, then there is no j which is a prime divisor of I. So you can safely you have to use you can mark it with one, right? And let's suppose you are having a looking at a number j or k whose prime divisor which is not prime, then in that case you can't use that color. So you can color it with two. So what you can do that for all the prime number you give that color one. Now let's suppose this is not a prime number. So and these are its prime divisor. So you can safely give it two and it will not be equals to one. So in the worst case you need two color, but if n equals to one, then you need only one color. Because in this case you have only one jewelry that is of price 2 and you give it 1, but, and you give it 1. And also for n equals to 2 you have 2 comma 3, you need only one color, but as you go up to 4 or 5 then you need at least two color. Means you mark all the prime number with color 1 and all the composite number with color 2. So let's see the code. So in this case you first find prime number to n plus 1. This will store the prime number. If the ith index is true, then it is a prime number. So if n is greater than 2, there will be two color and else one color. You iterate from 2 to n plus 1, and if that is a prime, you color it with 1, otherwise color it with 2. So this is a different color. Let's submit this. I have already submitted this and it's accepted. Thank you. And if you have any doubt, you can comment.